Welcome to Hyperphysics. In this video, I'll be showing you a very easy method to find average energy of nonlinear systems from Hamiltonian. So let's get started with the video. Okay, here's a question that we can solve. Consider a system in contact with heat bath with having temperature T is under nonlinear potential given as a Hamiltonian, and where A, B, S are constants and C is the speed of light. Now an observer makes a measurement of the system. Find the average energy of the system as measured by the observer. So you can see that the Hamiltonian has x to the power 4, by cube and 1 by z term. So usually if you are trying to do the equipartition theorem by solving this quadratic, seeing the quadratic terms, you can't solve this problem. So but there is another way to do this problem very easily. So the theorem is the general formalization of the equipartition theorem itself. So for any system, any canonical coordinates or phase space variable, what you can do is you have this kind of formalism like xm dh by dxn will be delta mn kbt, where delta mn is the Kronecker delta, where it's equal to 1 when m equal to n and equal to 0 when m not equal to n. Okay, this xm can be any phase space variable like canonical coordinates q or p. So if you use this method, we can solve this question very easily. We don't have to do any integration or anything. So I'll write this Hamiltonian again here. Hamiltonian h as c square root of px square plus py square plus pz square plus ax raised to 4 plus by cube plus s by z, right? So what I'm going to do is, first I'll do this part where these canonical coordinates x, y and z is there. So in general I can write in terms of coordinates, I can write x dh by dx, where x is the x coordinate, is kbt, and similarly is equal to y dh by dy is equal to z dh by dz, right? So we are going to do this thing to find the average energy of the potential part, or this part where ax raised to 4 plus by cube plus s by z term is there. So we'll first see this part where x term is there. You can see x, if you calculate dh by dx, it will be 4ax cubed, and you can multiply it here. 4ax cube has to be equal to kbt, right? So you can write 4 times ax raised to 4 has an average value of kbt, or average value of ax raised to 4 will be 1 by 4 kbt. And similarly for y, you have for y, that you can see that dh by dy is 3by square, and this thing y dh by dy will be y times 3by square, that will be equal to kbt, and this will be 3 times by cube, that will be equal to kbt, and the average value of by cubed will be 1 by 3 kbt. So we have gotten the average value of this thing, x raised to 4 and by cubed, to be 1 by 4 kbt and 1 by 3 kbt. Now we are left with s by z, and we need to find z dh by dz, and which is equal to kbt by equipartition theorem, general equipartition theorem. And we know that dh by dz will be minus s by z square, and if you substitute it here, you will get z times minus s by z square will be equal to kbt, and this will be minus of s by z, average of s by z will be kBt, or the average of S by Z, which implies average of S by Z, will be equal to minus kBt. So we have gotten the values for these things, ax raised to 4, by cube and S by Z. And we are left with one potential, then one kinetic energy part, where H is the kinetic energy part, where this is C square root of px square plus py square plus pz square, right? We have this term. So in general, if you can take any coordinate like PR, let's say PR, it's an R coordinate system, R theta phi coordinate system, R, the radial part will be PR square will be px square plus py square plus pz square, and we can see that we can replace by PR square root of PR square, that is PR, or the kinetic energy part will be C times PR. And I've already mentioned this method can be used for any canonical coordinates. So we can write for this part, we can write PR dH by PR will be also equal to kBt, right? And we take the derivative, will be dH by dPR will be C, and we have C times PR itself as kBt. So we have gotten all the values for the average energy, for the kinetic energy part, as well as the potential energy part. So I'm just going to write it like this: the total energy, the total average energy will be the summation of kinetic energy part as well as the potential energy part, potential energy, and this will be equal. This we have seen that it's C times PR. This thing, it will be kBt, right? So this is kBt, and we have the potential energy terms as 1 by 4 kBt, 1 by 3 kBt, and minus kBt. And we'll write like this: 1 by 4 kBt plus 1 by 3 kBt minus kBt. So you can see that it's 1 by 4 kBt, 1 by 4 plus 1 by 3 times kBt, right? And this will be equal to 7 by 12 kBt. So using this equipartition theorem, this general formalization of equipartition theorem, we can solve this question very easily, and you don't need to do any integration to solve this problem, as it will take a very long time to do this integration. And you can see option C is the correct answer for this problem. So I hope you like this trick, and please make sure you subscribe for similar contents like this, and don't forget to share with your friends. And thank you everyone. Thank you for listening. Thank you.